Welcome to Zigmatech Learning Hub. I will be your instructor for agricultural science. For this class, we are going to be taking our exercises from the Examguide app. If you don't have the application already installed on your device, I will want you to download the app in order to follow along in this class. Examguide is the leading educational app that helps students prepare adequately for various exams like UTME, post-UTME, WAEC, GCE, KCPE, IJMB, JUPEB, KCPE, BECE, JSCE, NCEE, NECO, to mention a few. You can download the app from www.examguide.com or Google Play Store. Please subscribe to our channel and turn on the notification bell to be updated on new videos. Ready for today's class? Okay, let's get started. So, this is the uppermost part of the earth on which plants grow. Now, soil takes millions of years for it to be formed, and the soil can be formed as a result of the weathering of rocks, which has to do with the breaking down of rocks. Now, this can be achieved mechanically or physically. It can also be achieved chemically, and it can also be achieved biologically. So in this topic, we'll be talking about soil formation and profile development. So our topic for today is soil formation and profile development. And by the end of this lesson, you should be able to define soil. You should also be able to state the factors of soil formation. You should also be able to outline the processes of soil formation. And finally, you should be able to describe the soil profile development. Now, what is soil? Let's take a look at the definition of soil. It said it's the uppermost layer of the earth crust on which plants grow. So the part of the earth where plants grow, which is the uppermost layer of the earth crust, is called soil. And soil is formed from the weathering of rocks, which has to do with the breaking down of rocks. So soil is formed from weathered rocks and organic matter. Now, what are the factors that affect soil formation? Now, the nature of soil that is formed in any area depends on some factors, and these factors include the parent material, which is the parent rock. Remember, we said soil is formed from rocks. Also, the climate, topography, biotic factors, which has to do with living organisms, and time. So these are the factors that affect soil formation. Now, starting with the parent material, or the parent rock. Now, the nature of the parent material determines the kind of soil that is formed. So the parent material helps to determine the color, the texture, the nutrients available, and the structure of the soil that is formed. For example, we have granite, which is an igneous rock. This type of rock gives rise to a coarse and acidic sandy soil, while basalt, which is also an igneous rock, gives rise to fine-grained alkaline clay soil. And soils that are also rich in ferromagnesium minerals are usually red in color and rich in iron. So you can see how the parent materials do affect the type of soil that is formed. We have climate as another factor affecting soil formation. Now, climate includes things like temperature. So we're going to look at temperature as a factor under climate, how it affects, let's see how it affects soil formation. Now, temperature has to do with the alternative heating and cooling of rocks. And as a result of this alternative heating and cooling of the rocks begin to expand and contract. So when it heats, it expands. When it cools, it contracts. So this heating and cooling alternatively causes the rocks to eventually crack. And once they crack, they break down into pieces, which now forms soil. We also have another climatic factor, which is rainfall. And rainfall has to do with the action of running water from rain. And as the water is running, it causes some gradual wearing of the rocks during erosion, and this helps to form soil. Now, rainfall can also enhance vegetative growth of our plants, and as these plants grow, the roots of these plants are able to penetrate rocks, and once they penetrate the rocks, it can lead to the rocks becoming cracked or causing the rocks to break or crack, and as a result of that breakage, the rocks will eventually break down to form soil. We have wind as another climate. So we've looked at temperature, we've looked at rainfall. Now we're looking at wind as a factor under climate affecting soil formation. Now wind has to do with high wind velocity in desert areas can cause these tiny rocks, to collide with one another, and as they collide with one another or other rocks, it now leads or eventually leads to the breaking of these rocks into tiny pieces to form soil. We have pressure as another element of climate that can affect or cause soil formation. Pressure, high pressure on hanging rocks can cause these rocks to fall down, and when these rocks fall down, they can break into tiny pieces and eventually lead to the formation of soil. We also have topography as another factor affecting soil formation. Now, topography has to do with the shape of the land. Now, if it's slopey, it will encourage the runoff of water, and this will now cause erosion, leading to the formation of soil. So we have, if the slope is steep, it will encourage erosion, and once this happens, the rate of weathering will be fast, and weathering has to do with the breaking of rocks. But if the slope is flat, maybe probably a flat land or a gentle slope, you will find out that the rate of weathering will be slow, because the climate will be evenly distributed, and in this case, the rate of weathering will be slow as against if it is a steep slope. So soil formation is usually faster in valleys than in slopey areas. Biotic factors, this has to do with the living organisms, and this can also affect soil formation. Now, these living organisms here include organisms like termites, earthworm, and rodents, and they also help to speed up the process of soil formation. How do they achieve this? They help to mix minerals and organic matter together that are found, and this results in the formation of soil. And also their activities, their burrowing activities can help also cause the rocks to crack and break, and as a result of this, it allows those cracks and breakages or crevices or allows water and air into the rocks, which will eventually break down these rocks to form soil. Time also is a factor that can affect soil formation. So it takes millions of years for soil to be formed. So when weathering occurs or all other factors of soil formation take place, it will take time, or it takes time for the weathered rocks to form soil. So eventually when weathering takes place, you'll find out that there's really no change that is noticeable. But after a long time, after so many years, you will find out that these rocks will gradually form distinct layers which now make up what is called the soil profile. So as we go further, you get to understand what the soil profile is, which shows distinct layers of soil. But as we move forward, I'll talk about that. Now let's look at soil formation and profile development. Here we know that the first stage of soil formation has to do with weathering, while the second stage has to do with the action of the biosphere, which has to do with the living part, or the part of the earth that contains life. Now, weathering has to do with the breaking down of rocks to form soil, and when these rocks are broken down into tinier pieces, the soil is eventually formed after a long time. So let's look at, still on soil formation processes. I've defined earlier on that weathering is the process of soil formation. So the process by which rocks break down to form soil is called weathering. So that's the first stage of soil formation. And under this subtopic, which has to do with weathering, we're going to look at three types of weathering. We have the physical weathering, or physical process by which rocks are broken down. or by which soil is formed. We also have the chemical process or chemical weathering. That's the chemical process by which rocks are broken down to form soil. We also have the biological process by which rocks are broken down to form soil. And you can say I'm stating biological process or biological weathering, because weathering has to do with the breaking down of rocks to form soil. So starting with the physical process or weathering, now this has to do with the rocks being splitted into fragments as a result of the action of climate or things like temperature, wind, flowing water, ice, or glaciation. So ice is also known as glaciation. Now these factors can cause rock to break down or disintegrate. And once this takes place, it's called physical weathering. We also have chemical process or chemical weathering. We have, this involves the dissolution of minerals. Now rocks are made up of minerals, and once these minerals get in touch or in contact with water and atmospheric gases such as carbon dioxide and oxygen, new substances are formed, and as a result of this, weathering takes place, which is called chemical weathering. We have the biological process or weathering. Now, biological here, we're looking at living organisms. Now, these living organisms, their activities, probably their burrowing activities, can cause these rocks to break down to form soil. And here, these living organisms refer to plants, animals, and man. This picture helps us to see how that tree has been able to cause that rock to split into two and eventually causing it to disintegrate to form soil. So the processes here, we've talked about the chemical process or chemical weathering. We've talked about the physical process or physical weathering. We also talked about the biological process, which is also called biological weathering. Now let's look at the agents of these various types of weathering. We're going to look at the agents of physical weathering. We'll also look at the agents of chemical weathering, and we'll also look at the agents of biological weathering. Starting with the agents of physical weathering, we have temperature as an agent. And how does temperature cause physical weathering to take place? Remember, weathering has to do with the breaking down of rocks to form soil. Now, temperature, which has to do with the degree of hotness or coldness, in this case, causes rocks to expand when heated, and these rocks also contract when the rocks get cold. So this continuous expansion and contraction over time will now cause the rocks to crack and eventually disintegrate. So our focus here now is how the agents of physical weathering act on the rocks to cause it to break down or disintegrate. We have wind as another physical agent or agent of physical weathering. Now, strong winds can cause bits of rocks to break off. And these bits are eventually deposited elsewhere together with soil particles. So as the wind blows, it picks up the soil particles of sand and keeps on blasting the larger rocks with these particles, which will eventually lead to the disintegration of the rocks to form soil. We have water as another agent of physical weathering. Now here we're referring to running water from rain or streams or rivers, which can carry away rock particles of various sizes, and as these rock particles are moving, they begin to rub and knock against each other, and that impact will now cause the rocks to break or disintegrate to form soil. We have ice or glaciation. Now in this case, you can see that the cracks or crevices that are in rocks, water could get filled into those cracks or crevices, and as this water freezes at low temperature, ice is formed, and once water freezes at that low temperature and ice is formed, the volume increases to about 9%. Now, as the volume increases, it exerts pressure. Pressure is now exerted within the rocks, and as a result of that, the rock will begin to crack and eventually shatter. So when the temperature rises, the ice will now melt, and once it melts, the water will now carry the shattered pieces of the rock away and eventually form soil. Let's take a look at chemical weathering now, the agents of chemical weathering. So we will get to understand how these agents of chemical weathering lead to the breaking down or disintegration of rocks to form soil. Now, these agents of chemical weathering include carbonation, which can also be called types of chemical weathering. They include carbonation, hydrolysis, hydration, oxidation and reduction, and we also have solution. So starting with carbonation as an agent of chemical weathering or a type of chemical weathering, here we're looking at carbon dioxide in the atmosphere, which now mixes with rainwater to form carbonic acids. Now, these carbonic acids will cause rocks to break down and disintegrate. So that is carbonation as an agent of chemical weathering. Now, hydrolysis as an agent of chemical weathering also has to do with the reaction of water with rock minerals. And this reaction leads to the procurement of a rock which is different from the original rock that existed. For example, we have a rock that is called olivine, and once water gets in contact or reacts with the rock minerals, this olivine rock is changed to serpentine, which is usually softer and weaker than the original olivine rock, and this will eventually lead to the breaking down or disintegration of this rock. So this process is called hydrolysis. We have hydration. Now, this also involves water and rock minerals. Now, in this case, the water combines with the rock minerals to form what is called crystals, and these crystals will now cause the rock structure to get weakened, and once it's weakened, the rock will eventually disintegrate. Now, an example here is hematite, which combines with water to form limonite. And another example is anhydrous copper tetrasulfate 4, which now reacts with water to form what is called bluestone. So this is what is called hydration as a means of weathering, chemical weathering. We have oxidation and reduction. Of course, oxidation has to do with the taking up of oxygen from the atmosphere by an element or a compound during weathering, and oxidation has to do with the loss of electron, while reduction has to do with the gain of electrons. So once these rock minerals react with atmospheric oxygen, they get weakened, and eventually the rocks break down to form soil. So this also still explains oxidation and reduction. So you can see oxygen, if oxygen reacts with a mineral ion, for example, you find out that the rock is now converted, as the rock mineral is now converted to iron oxide, which is now seen as a reddish brown crust. Now, this conversion will now eventually cause the rocks to disintegrate. Okay, still on oxidation reduction, you can see iron, when oxygen, which is dissolved in water, reacts with the mineral ion in the rock, this now converts that mineral ion into iron oxide, which can now be seen as a reddish brown crust. And this conversion weakens the bondings, and you can see that it will eventually lead to the disintegration of the rocks. Solution is another chemical or agent of chemical weathering. Now, this has to do with water as well. Water now dissolves soluble minerals that are present in rocks, and as a result of this dissolving of these soluble minerals, the rocks, they are carried away from the place of reaction while the water flows, or they could be accumulated in the place of reaction. Let's look at biological weathering. That's the agents of biological weathering. Now, the first agent we have here is what is called microorganisms. Now, how do these microorganisms cause weathering of rocks? Examples of these microorganisms include earthworm or termites and some other soil organisms that could burrow into these rocks And these burrowing activities can cause the breaking off of fragments of rocks, which eventually would form soil. We have organic activities. Now this has to do with plant roots. You can see that these plant roots can eventually, or animals like burrowing worms, can cause these rocks to break down, and this will eventually lead to soil formation. Human activities is another agent of biological weathering. Now how does human activities cause weathering? You can see construction works, quarry, which has to do with the breaking of rocks, and also sand excavation can also have, or do also have, great significance in the breaking down of rocks. Now let's look at the soil profile. Now, soil profile has to do with a vertical section of the soil which shows series of different horizontal layers or different horizons of the soil, or of different types of soil, from the surface to the underlying beds of the soil. So the soil profile has to do with a vertical section. Vertical means from top to the bottom. So you can see showing the different horizons or different layers or horizontal layers of different types of soil that can be seen. So that's what the soil profile is. Now, in humid areas, you can see the soil profile, such as the forest zone. You can see the soil profile has 4 distinct horizons, where we have the A horizon, the B horizon, the C horizon, the D horizon, or the R horizon in some cases. So the A horizon is the topsoil, the B horizon is the subsoil, the C horizon is the parent material, and the D horizon is the bedrock. Now, these are the 4 distinct horizons that are seen in the soil profile. Now, when you look at the soil profile, the first thing you will observe in the soil profile are the different soil colors. So from that picture, you can see that there are different soil colors. So the topsoil is usually dark, followed by brown, and so on. Then you can also see another feature that is observed in the soil profile has to do with the texture or the particle size, which also increases from the top. That increases its size from the top of the soil profile to the bottom of the soil profile. So as you go down to the bottom of the soil profile, you have larger sizes of particles of soil. Now, starting with the A horizon, remember we're talking about the A horizon, the B horizon, the C horizon, and the D horizon. The A horizon is also called the topsoil. Now, this represents the surface layer of the soil profile. Now, this layer contains more organic matter than any other horizon, and is also the most weathered horizon and the most leached. Now, leaching has to do with the washing away of nutrients beyond the reach of the roots of plants. So it's the most weathered, and it is the most leached of all the horizons, and it's suitable for the cultivation of certain crops like vegetables, legumes. Those are crops that are not deep rooted. So they are shallow rooted crops. So it's suitable for such crops. That's at the A horizon. While the B horizon is also known as the subsoil, and is the next horizon after the A horizon, which contains the topsoil. Now, it's also rich in minerals which are leached down by percolating water, and is suitable for deep-rooted crops like cocoa, rubber, orange, tree crops as well. We have the C horizon, which is called the parent material. Now, this is derived from the topsoil and it is materials from the topsoil, from where the topsoil and the subsoil are derived. So the C horizon is where the topsoil, where the materials that are for the topsoil and the subsoil have been derived or are derived from. Now, it's the parent material, which are small fragments of rocks. And these small fragments of rocks are unweathered, and they are found at the bottom of the profile. We have the D horizon, which is called the bedrock. It also represents unweathered rock materials and is found at the bottom of the soil profile, and it usually contains large soil particles. Let's look at the importance of the soil profile. Why is the soil profile or knowledge about the soil profile important? Now, it is suitable, or the suitability of a soil for agricultural purpose is determined by looking at the soil profile. So if you want to know whether a soil is suitable for agricultural purposes, you need to take a look at the soil profile. Now, one of the importance of the soil profile is that it helps us to know the level of soil fertility. So once you have a thick topsoil, such topsoil represents a high level of soil fertility. It can also help us to know the type of crops to grow. Remember, I talked about shallow-rooted crops and I talked about deep-rooted crops. So you can see that shallow-rooted crops grow on the topsoil, while shallow-rooted crops like, of course, groundnut, maize, cowpea, grow vegetables. They grow on the topsoil, while deep-rooted crops like our tree crops, oranges, lemon, rubber, cocoa, do grow in the subsoil. Which has to do with the B horizon. So now we can also know about the penetration of roots through the soil profile. Now a soil or a loosely packed subsoil will always allow for easy penetration of roots of our crops. So the roots of our crops, if the subsoil, which is after the topsoil, that's the B horizon, is loosely packed, the roots of our crops can easily penetrate. So that's another importance of the soil profile. We also have level of drainage and aeration. Of course, drainage has to do with the movement of water within the pore spaces of our soil particles, and aeration also has to do with movement of air. So a loosely packed subsoil will also ensure that there's easy drainage and also aeration. So we're able to know the level of drainage and aeration as a result of our soil profile, knowledge of the soil profile. Another importance is easy percolation. If the subsoil is loosely packed, there will be easy percolation of water, which has to do with the absorption of water or the downward movement of water, and this will help to prevent erosion. Okay, we've learned so far quite a number of things, but let's just have a recap on what we've learned. I started by defining soil. I said soil is the uppermost layer of the earth crust on which plants grow. And the nature of soil formed in an area depends on some factors, and these factors include the parent material, climate, such as temperature, water, wind, topography, that's the slope of the land, biotic factors, which are living organisms like termites, earthworms, then also time. These are factors that can determine the nature of the soil that is formed in an area. Then we also looked at weathering, and we defined that the process of soil formation is called weathering. We also looked at the various types of weathering or the processes of soil formation, which includes physical process or physical weathering, chemical process or chemical weathering, chemical process, and biological process or biological weathering. And we also defined soil profile as a vertical section of the soil showing a series of different horizontal layers or horizons of different types of soil from the surface to the underlying bed. And we also looked at the importance of soil profile, and we looked at it looking at the level of soil fertility. It also helps us to know the type of crops to grow. We also looked at the processes of soil formation, which has to do with weathering. And here we're looking at we talked about physical process of physical weathering. We also talked about chemical process, chemical weathering, and also looked at biological process of biological weathering. We also defined soil profile as a vertical section of the soil showing the series of different horizontal layers or horizons of different types of soil from the surface of the soil to the underlying beds. We also looked at the importance of soil profile, which includes the level of soil fertility, helping the farmer to know the level of soil fertility, also helping the farmer to know the type of crops to grow, also looking at the penetration of roots, where we're talking about shallow rooted crops and deep rooted crops, and also the level of drainage and aeration. So let's take a look at some questions using this. So the diagram below illustrates a soil profile. They said we should study it. Now, the soil horizon that is not supportive of the growth of tree crops. Horizon A, B option horizon B, C option horizon D, and D option horizon D. The answer should be D option, that is the bedrock. And at that point, the disintegration of rocks, the rocks are still very large and have not been disintegrated. They have large particles. So the place that supports the growth of tree crops is the A horizon, the B horizon, and the C horizon. The answer is D. So which of the following agents is not associated with chemical weathering? So the agents associated with chemical weathering, if you can remember, we talked about hydration, hydrolysis, solution, oxidation, reduction, carbonation. So A option here says oxidation, B option pressure, C option hydrolysis, D option carbonation. The answer here is pressure. So this question says, in chemical weathering of rocks, the equation, this is iron oxide plus 3 molecules of water. With this water, you can see we're talking about hydration, forming hydrated iron oxide, which gives us this equation here. So they said in chemical weathering of rock, this equation represents A, carbonation, B, hydration, C, solution, D, oxidation. So the answer here is hydration. Okay, this question says soil profile is important in agriculture because it A, determines the soil certina, B, determines the type of land tenure system, C, it gives indication of the type of crops to grow, and D, promotes the weathering of rocks. The answer is C, it determines or gives indication of the types of crops to grow. Thank you for participating in today's class. You can practice more questions using the Examguide app. The app scores and gives a detailed explanation of all the questions at the end of your practice test. You can learn a particular topic of interest with different modes like study mode, mock mode, and practice mode. It also has other features that make learning fun. It is a must-have for all serious students. Download from www.examguide.com if you don't have it yet. See you in the next class. Don't forget to subscribe to our channel, hit the notification bell, and share the video to people that would benefit from it.